start now with the introduction to ADAS webinar. So firstly, I'd like to start with a history of how ADAS is. So as you know, basically ADAS is a domain of the automobile industry. And the automobile industry, it all starts from the time the wheel was invented. And that has been around for a really long time, all right? So like ages ago. And so as it started and as technology kept improving and with the industrial revolution, this thing around the last century, ADAS started coming in slowly. And so when the main feature of ADAS was that it was trying to help assist drivers in their the work. So before that, everything, braking or acceleration or steering, all of that was solely focused on only a driver's skill. So if there is a sudden obstacle in front, or if there is a sudden curve, or if you are not positioned in the center of the lane, everything depends on how well the driver knows how to handle it. The driver should be able to handle it back. The driver should be able to judge the distance between him and the obstacle in front and stop. That was how the situation was before all these driver assistance systems came in. But then around 1948, as I mentioned, as you can see here, these ADAS systems started coming in, and slowly it started helping the drivers in their daily work, in their daily in the systems and in the cars. It was just a little extra support. So at first, as you can see here, cruise control. So what cruise control does is basically that is like one of the very first features of ADAS. So cruise control is a feature wherein if the driver can set a speed, for example, you're on a highway, and then you decide that there is, when you travel on highways, especially, you'll notice that at some point of time, there is no necessity for you to be constantly vigilant about all what is going on around you. That is a nice empty stretch, and you can actually relax a bit. By relaxing, I mean not completely taking off your focus, but just sitting back and letting the car go at a particular speed. But that couldn't be achieved before ADAS. Before ADAS, to maintain a particular speed, you should always be active. You should be clear that, okay, my car should maintain the speed limit of 55 or 60 kilometers per hour. But once the cruise control setup, the parameter came in, the driver could mention the speed. Like this feature will allow the driver to mention a speed saying, I want the cruise to be maintained at, let's say, 50 kilometers per hour. So then the vehicle maintains that speed. That is, again, you have to note very carefully, that is only if there is no other outside disturbances. The moment anything else, the moment some other obstacle or vehicle which is lesser in speed than you are. So for example, you're traveling at 50, the set speed, it's cruise control. And then a vehicle in front of you is traveling at, let's say, 45. Then immediately this cruise control feature will alert you, mentioning you have to take it over. So this beginning feature, as mentioned here, was a driver assistance. So when you needed it, when you needed to relax on the highway, cruise control was there to assist you. So that, as you can see, is like a basic. This is the basic of ADAS. So with this base, we will go further into all the how this domain developed, what other features came, and how this cruise control itself was, highly developed into what the current state it is in right now. So I hope you understand that basic of ADAS. Now let us go into adaptive cruise control. So now, as I mentioned here, cruise control is when you give a speed, and when there is no other obstacles, the vehicle maintains that particular speed. But when adaptive cruise control will help in such a way that even if the front target vehicle is at a speed lower than you, it will adjust your vehicle. So you see again, one more step. So first, let's say you have an assistance level of, on a scale of 1 to 5, you are assisted on a level of 3. And now when adaptive cruise control comes in, you're assisted on a level of 5 itself. Then again, so now the comfort level, the support level for the driver has increased one step. In cruise control, the driver could only relax when there is no obstacle or target vehicle. But now the driver can relax even if there is an obstacle or target vehicle, because your vehicle, and by the way, this is an important term, like as you enter into the industry, you will know, this is how we usually term the vehicles. The vehicle you are talking about, the vehicle that you are driving, is always referred to as ego vehicle, EGO, ego vehicle. So you should always remember that, since I will be using that term as we proceed further with the webinar. Ego vehicle is the vehicle that the driver is driving. So we will be using that term. So please remember that. And all other vehicles we will mention too as target vehicles. So like I said, our vehicle, the ego vehicle, now the comfort level has increased for the driver. Even when there is a target vehicle in front, which has lesser speed, adaptive cruise control will help and control the speed based on the front vehicle speed. All right. So this is just the basic, like two basic parameters of driver assistance. If you ask anyone in ADAS, this is like one of the first features they will talk about. And I'm just mentioning a few more features, which I will explain further to you. Some of it is forward collision warning. So forward collision warning is when there is a obstacle in front and your vehicle is moving, and that, let's say, there is always these parameters called safety distance for each vehicle, for each company. All right, the safety distance parameters will vary. And there are some of these national standards also, like for example, some standards which you can note down are NASHTO standards and the American Europe standards, etc. These standards will specify what is the safety distance to collision. That is, within this distance, if the distance reduces between you and your target vehicle, then immediately this forward collision warning or AEB must be activated. So in such a case, like I was mentioned, if suddenly the distance is lesser between your obstacle and your target vehicle, then this warning comes up. It pops up on your HMI interface. HMI here refers to human machine interface. All right, so this actually is a separate domain as such, all HMI controls, etc., and all that. It works very much integrated with ADAS, because anything we do in ADAS, it is about informing the driver, because as the name mentioned, it's a driver assistance system. So HMI is what assists the driver. So in this forward collision warning, a warning comes up to the driver saying you will be colliding, so you better override now, take control, or be prepared for a imminent collision. So that is what forward collision warning does. And in advanced emergency braking, it is similar, very similar to forward collision warning, except that the system, that is our ECU here refers to engine control unit. You can note that down also. So our ECUs here will control the brakes too. So this ADAS ECU will be sending a message to the brake telling, put some more brake. Now there is an imminent collision which is going to happen. Help our driver. I mean, he shouldn't go and crash. Help him. Put a little more pressure on the brake to help our driver. So that is what happens in advanced emergency braking. And then lane keep assist over here. It's very important. I don't know, in India as such, you may not see it, like often we notice people just cutting in as they please. But when it goes to European countries or American countries, etc., they're very particular about maintaining their lanes. The minute anyone cuts a lane, it's like a punishable offense there. I mean, even here it is, but no one takes it seriously. But over there, it is very important to maintain your lanes. So lane keep assist helps in such a way. For example, you're on a highway now. Let's say you're on a 6-lane highway, and then suddenly you feel, I don't know, you're talking to your co-passenger or some of the other people in the car, and without your knowledge, you're moving away from the exact center of the lane. All right. This actually in such a way now, over there in the other lane, even though you don't exactly move into other lane, it can disrupt the line of vision. They use this term also often, LOV, the line of vision of the target other vehicles to your right hand side or left hand side, and it can cause accidents. So that is why LK is very important. So anytime you're moving away from the exact center of your lane, you will get a warning mentioning you're 0.3 meters away or 0.5 meters away from the center of the lane. So that lateral control, the lateral steering and lateral acceleration will be tweaked in such a way, it will give you a little support or a push on your steering wheel to bring you back to the center of the lane. That is what lane keep assist works at. And then coming to traffic jam pilot. Traffic jam pilot actually, it is used in such a way, it is used especially when your car is in a traffic jam. So now imagine this situation. You're heavily surrounded, like there's for a long stretch ahead of you and behind you, you only see traffic. So there's actually nothing much for you. You just have to sit there. Whenever your vehicle in front of you moves 2 meters, you will again move 2 meters and again move 2 meters. Nothing else for you to do but just sit and keep accelerating a little, a little. So if you see, won't that be a monotonous task? As a driver, imagine how irritating it will be for you to just keep, press the accelerator, move a little front, press that, move a little front, but no continuous movement. That can cause leg pains, that can cause irritation. So this traffic jam pilot, what it does is, when it identifies, when the system identifies that, okay, this is a high traffic situation, so there is nothing much for the driver to do. And since it is in the traffic, if you notice, we will be moving in maximum 10 kilometers per hour and in small intervals only, right? So the system decides, okay, I can help the driver, I can take care of this myself. Why does the driver have to worry himself for such a small amount of movement or time intervals? So in that case, what happens is, traffic jam pilot, it first identifies if the situation is a traffic jam. And some parameters to identify if it's a traffic jam is to see if all the vehicles, these are some parameters which are used when you create the scenario. So please note it down if possible. If they will hit the vehicle, the system will notice if all the vehicles around it are lesser than 40 kilometers per hour, and if the distance is lesser than a given safety distance. That differs from company to company. You will have to, it will be based on the safety parameters or safety standards they follow. So if it is such a case, if the speeds are lesser than 40 and if the distances are lesser than a given distance, then the system decides, okay, this is a traffic situation. So it asks you, are you willing, like I can take care of this, all I have to do is just make sure and move, right? So then if you activate that TJP, the traffic jam pilot situation, the driver can relax and the vehicle will take care. So now these are just some of the very basic features of ADAS. There are many more nowadays, like many have been developed. I just, for an introduction, this is what I'm trying to explain to you. So now that we've understood what ADAS does and how it supports the drivers, we will move on to the different levels of ADAS and more technical stuff into ADAS. All right. Yeah. I hope you're still with me. Any doubts, please feel free to write in the chat and I'll get back. So now, coming back to the different levels of ADAS, the technical part of ADAS. So if you see now, when even ADAS, any domain, it should always be very much streamlined, and it should always have proper levels of development, because only then will you be able to properly align yourself. Because if you see this one ADAS domain, all OEMs, all tier 1 supplier companies, they work on this. So when they work on this, there should be this global level of alignment or a global standard everyone follows, correct? So this is what the different levels of autonomous driving does for us. So if you see here, when an OEM, by the way, the full form is original equipment manufacturers. So all the famous car companies, they come under it. Yeah. So when an OEM develops its basic car model, a nice proper car model with none of these automation features, then it is level 0 vehicle. Okay, level 0 vehicle means there is absolutely no automation. And in other terms, if these are a little more technical terms, so try to keep up. In a little more technical term, if you mention, like from how we do the work on it, is like hands-on and eyes-on. So if you get it, meaning the driver should always have his hands on the steering wheel and his eyes should always be very active about what is going around. So that is what level 0 no automation means. Meaning the hands should be on and the eyes should be on. So he should be constantly aware of what is going on around him. So that is what level 0 does. He cannot relax anytime because there is no ADAS feature to support him. And then when you come down to level 1, so in level 1, in driver assistance, even here again, the hands-on, eyes-on, both should be there. But the only thing is there will be a little extra support. For example, a very common example that we can help us understand level 1 is power steering. So power steering comes now, if you see in many vehicles, it has become a very common feature. Like that is like a base level ADAS feature. So power steering is like that, a little bit of a support which it gives us. So that comes under level 1, driver assistance. All right. And even here, though, Even though if you see even power steering also, your hands-on eyes on should still be there. The driver still hasn't reached a level of relaxation of either your hands or your eyes. So now next level we move on to is level 2, partial automation. This is the level that nearly more than 80% of OEMs are currently working on this level only. So this is the level which where the production is coming out, and majority of the cars which have come out in recent years also, they follow this level of ADAS only. That is partial automation. The basic features which I explained to you, like AEB, ACC, and TJP, all of that comes under this level 2 partial automation. All right. So in this thing, it's like the most safety critical setups, like it's mentioned here, the very safety critical features and all that, that is still controlled by the driver only. It depends on the driver. But some extra support for, like, so like I mentioned before, in ACC or TJP, if the situation is safe and there is nothing, for example, TJP, it's only a traffic jam, nothing else to worry for now, then the system can take control. But then again, it depends on the driver's consent. So if the driver decides, okay, I can rest a little while in this TJP situation, or this free highway, there is nothing to affect me right now, I can rest a little. In that situation, then the system can take control, that too not fully. Anytime the driver has the capacity to override. So that is only level 2 partial automation. In this, based on the eyes and hands example I was mentioning, here your eyes should be on at all situation. Hands can be off only in safety non-critical situations. That is what level 2 refers to. Now moving on to level 3. Level 3 is where all OEMs mostly right now it is in the research stage. Like I mentioned, level 2 is most common because many level 2 cards have come out already. Level 3 is currently in the R&D, research and development stage. So people are working on how to, the level 2 cars which they have given out in the market, they are now trying to develop it, to upgrade it to level 3. So level 3 is conditional automation. All right. So it is like very, frankly speaking, it's pretty similar to level 2, except that even safety critical functions, like anything, even an accident sort of situation also, if the driver consents, the system can take care of it. Like in level 2, safety critical, it was not an option, not major, it won't be tuned, set up in such a way that the driver can just leave it to the system. But in level 3, even the safety critical functions can be left to the system if the driver decides to. So that is the little bit step up. So when here it is as usual, when coming to eyes on and hands on, your eyes on should always be there. Hands on, eyes on and hands on, but both eyes on and hands on can become eyes off and hands off if the driver decides. So if you're following the flow, I hope I'm not confusing. If you're following the flow, level 0 is eyes on and hands on, meaning eyes always on steering wheel, hands always on steering wheel, eyes always active. Level 1 is again eyes on and hands on. Level 2 is eyes on and hands on, but hands can be off if the driver decides. And level 3 is eyes on and hands on, but both eyes on and hands can be off if driver decides. So I hope you're seeing how it proceeds, how the levels are developed. All right. And then now coming to level 4, high automation. So this level is actually one of the most famous OEMs, like in Europe and all, like the hi-fi OEMs which you read about, they are onto this right now. Most probably by the plans mostly were by 2020 or 2021 to get such working prototypes on the road. So in this high automation, the vehicle can become completely autonomous, meaning eyes off and hands off. But then again, only when the driver decides. In safe conditions, when the driver decides, vehicle can handle it. So that means like a very normal situation also. Your full trip from your home to your office, if you decide, the car can handle it, no issues for me, then you can put it in full automation and just relax and the car will take over. Eyes off, hands off completely, no worry. That is what level 4 does. And then moving on to level 5, here that is high automation. Moving on to level 5, Even the driver doesn't have to choose and tell you should go into automation. In level 5, the cars are such that you just mention, okay, I have to go to my office at like Google Maps. You just enter a destination, the car will take you automatically. That's all. So that is how the levels work, if you see. So in level 4, it is the driver's choice, saying I choose for it to be fully automated. But in level 5, there's no choice, nothing. The car is automatically fully automated. All you have to do is just enter the destination. So these are the 5 levels. So if you see different industries, even when they talk to each other, when you talk to your clients also, this is how you talk. You say, I'm doing a level 2 feature assessment. Or are you working on level 3 research and development? This is how it works. So this is like a basic of the ADAS domain. Anything, any work which is done in ADAS domain is based on these 5 levels only. All the parameters, all the coding, etc. you do will be based on what sort of car you're working on, whether it's level 2 car or level 3 car, and so on. All right. So this is like a base introduction.